On your asynchronous lecture of last Thursday, you saw that we talked about periodic table. And we said that there are periods in periodic table, the horizontal rows, and there are groups in periodic table. And we said elements are in the same group because they have similar properties. And in periods, the shell number of the outer electrons of an atom changes. So if you know the period number and group number, you have the address of finding an element. And we said some of these groups have specific names: alkali metal, group 1A; alkaline earth metal, group 2A; halogens, group 7A. And we talk about noble gases. They are called noble because they are very stable. They don't need to react to become stable. But every other element in the periodic table is looking up to them. They want to be like one. They want to lose, gain electron, or share electron to look like a noble gas. And then we talk about prefixes. We say that these prefixes can come before any unit. It can come before liter or meter or grams, and they have certain meaning. So we said giga, if you say gigawatt, it means 10 to the power of 9 watts. And if you say microgram, you mean 1 millionth of a gram. And you use the letter mu for that. So this table will be available for you on the exam table. Those of you who haven't taken course with me, on the canvas, there is a table which I give you, which is called exam table. You can open it during the exam, look these up. Just before end of previous lecture, we talked about conversion between different scales of thermometer. And we showed you the formula which relates these three scales together. So Kelvin, you might remember, is adding 273.15 to Celsius. And we said 0 of Kelvin is 273 degree below 0 Celsius, or 0 Celsius is 273 K. And if you want to calculate Kelvin, just take a Celsius at 273, so 100 degree of Celsius is 373 Kelvin. And if you want to convert Celsius to Fahrenheit, we said this is the formula. 1.8, 9 over 5 is 1.8. 1.8 times of Celsius plus 32 gives you the Fahrenheit. And the reason was that 0 Celsius has been assigned 32 degrees of Fahrenheit. See, 0 Celsius, 32 degrees of Fahrenheit, and that's equal to 273 Kelvin. So I want to start with talking about scientific notations, why we use them, how do we convert scientific notation to standard numbers, or vice versa. Of course, you have seen this in Chem 2A before. So you might remember we said 1 mole is simply a certain large number of atoms, and this number of atoms in 1 mole what's called Avogadro number. It's a huge number. And we said 1 mole of carbon is 12 grams. It means in 12 grams of carbon, you have got this many atoms. How would you read this large number? It's not million, billion, trillion. It's a lot of zeros. So how do we read a number like that? In order to make it simpler, excuse me for a moment. In order to make it simpler to read these things, we write them in scientific notation. So if I want to show this standard number, I write it in scientific notation. It's easier to read, easier to write. It's going to avoid error. That's how we define 1 mole. 1 mole is 6.022 times 10 to the power of 23 units. The unit can be used for atoms or any other thing. The same way we say dozen is 12, mole is 6.022 times 10 to the power of 23 units. In case of atoms, there are this many atoms in 1 mole. Or suppose I ask you calculate mass of 1 atom of carbon 12. If 1 mole is 12 grams and there are this many atoms, all I have to do divide total mass by number of the atoms. That means you have to divide 12.0 grams by this huge number, and you're going to get this really, really small number. That's mass of 1 atom of carbon 12, and it's in grams. Again, we are dealing with extremely small number, hard to read, hard to use a unit, so many zeros before, and so many zeros after in this case. So again, using a scientific notation is going to help us and avoid error. And if we do, we get 1.99 times 10 to the power of negative 23 grams mass of 1 atom of carbon. So can I say what we are doing in scientific notation, we try to break down the standard number to a coefficient and a power of tens. Power of tens and coefficient. So I'm going to call this coefficient as n. N, by definition, arbitrary definition, has to be between 1 and 10. In other words, n can't be 0.5. It must be 1 and larger. And n can be 11. It has to be between 1 and 10. And what is n? The lowercase n is the power of 10. Power of 10. So that's how you write a scientific notation. So number n, uppercase n, is between 1 and 10. And the lowercase n is a positive or negative number. So if I go to next slide, this is a standard number. Guys, how do I write this in scientific notation? In other words, I want to first of all figure out the coefficient. Coefficient must be between 1 and 10. In order to make this number to 1 and 10, can I say I must move this decimal point once, twice? So I move decimal point to the right of the first digit. And if I do that, do I get 5.68762? Can I say my coefficient is now smaller than 10, larger than 5. So that's your coefficient. And then, of course, I must use the power of 10. And how many times power of 10 is coming from the number of times I move the decimal point. Did I move it 2 times? Did I move this decimal point once and twice? So twice is 2. Is it plus or negative? Obviously, 568 is much larger than 568. So the power has to be positive. Why positive? Because I move decimal point to the left. You see decimal point is moved to the left, the power is positive. Do you see the standard number has been reduced from 568 to 5? So I must have a coefficient which is larger than 1. 10 to the power of 2 is 100, it's larger than 1. So this is the scientific notification of the standard number 568.762. So if you move the decimal point to the left, then the power of 10 is larger than 0. That means it's positive. And that's the answer. Do you have any question? Anybody? Don't be shy, ask questions. Okay. Now, what if I have this standard number and I want to show it as scientific notation? Again, I need a coefficient which is between 1 and 10. So why don't I move this decimal point once, twice, 3 times, 4 times, 5, 6 times? Yes. So I move the decimal point to the right of the first digit. So can I say, no, I have 7.72? Is this between 1 and 10? Yes. So this is a good coefficient. What is the next part? Power of 10. What is power of 10? It's a number which is showing how many times I move the decimal point 1, 2, 3, 4, 5, and 6. So it's 6. I move it 6 times, not to the left. I moved it to the right. I moved the decimal point to the right. I actually make this tiny number much larger. So I should have negative power. So 7.72 times 10 to minus 6 is scientific notation of the standard number 0.0000772. Do you have any question? Anybody? Do you have any question? Are you sure? Looks like it's time for us to go. So this is very good. We are going to stop. I'm going to wish you a very wonderful day. Please make sure to study and get caught up. I will make sure to change the deadlines to weekend, although you have a whole week to plan it. Don't leave things to the last moment. I want to thank you for showing up to the lecture. Have a wonderful day. Anybody who has any question, please stay and ask questions.
Thank you, Dr. Fard.
Thank you, guys. Thank you, Victoria. Thank you, Bella. Anybody else? Questions?
Thank you.
Thank you, Max. Anybody has any question? Thank you all. Have a great day.